Hello young friends, how are you? Today I will study the resistor, capacitor and inductor. As you all know, this unit is about the use of these components in various networks. In the previous lecture, we have studied the current and continuity equation. Now we will study how current will flow when we have these components, passive components in the system. At the end of this lecture, we will be able to learn basics about resistors, inductors and capacitors. You will get insight of behavior of these in the networks, how these components works, how these components store the current, store the energy, how you can use these components in circuit. You will be able to learn various applications after getting this knowledge. Resistance is the first component that you studied a lot since beginning. Resistance gives the idea. Resistance means obstacle. Whenever current flows, how obstacles you put in the path, how you resist the passage of electrical current. This is called resistance, and this is measured in ohms unit. As this is clear, if you have a wire, then wire is having resistance R and the current is flowing, then this also depends on the length of the resistor you placed and the area of the resistor. We must know this, that if you impose more length, more resistive area for the current, the resistance will be more. And similarly, if you have small area from where the current can flow, from where the electron can flow, then will be the small area will give you more resistance. Resistance can be written as I told you, resistance is proportional to length, more resistance, and resistance is inversely proportional to A. Higher A, less resistance, lower area, more resistance. If these two, you combine these two proportionality quantities, then R is proportional to L by A, or if you get the proportionality by the equal sign, then this is rho will come into picture. Rho is called resistivity, a material's property. Another form to calculate resistance is applying Ohm's law. R is equal to V upon I. V is the voltage and I is the current. My friends, I always request you to get good collection of data. Here I am presenting very good slide of calculation of resistance. I expect all of you must keep this with you. This will also helpful in your experiments in the lab. Here I have shown a resistance. This is a resistor, and in this resistor you are observing several bands. First band, second band, third band and fourth band. So you have first you have resistor with bands. In this band you can calculate the resistance. The first digit, we have different color bands. The first digit is given by first band, second digit is given by second band, and third digit give you multiplier, how much should be multiplied, and the fourth digit is for tolerance. Here the color also shown here, black for 0, brown 1, then orange 2, then this 3, this 4, then 5 and so on. Here also check this color and put the values. You can calculate the color resistance. When we use resistance in network, it may be parallel, may be series. Here we have shown resistance in series. Two resistances are in series. If you have two resistance in series, then this will be added and the total will be R1 plus R2. There is another way to add resistances, that is parallel. If you put two resistors parallel in a network, in a circuit, then this is added by this rule. 1 upon R total is equal to 1 upon R1 plus 1 upon R2. Another important component is capacitor. Capacitor, we already discussed in some units, is used to store energy. Capacitance word is used to capacity, gives the capacity of a capacitor, capacity of storing energy. How much energy can be stored? Basically, it is a device. Because if you want to put more energy, then you can't use only single plate. You have to use two plates. In the capacitor, we have two plates. On one plate, we give charge and there is induced. And the outer side, we ground. We have several types of capacitor we will discuss here. And the capacitance is defined as C is equal to Q by V. Q is the charge supplied and V is the voltage between the plates. The unit of capacitor is farad. Here we have shown parallel plate capacitor. The capacitor with parallel plates. On the first plate, we supply charge Q. The both plates have area capital A. The distance between these two plates is small d. We have supplied charge q on first, that is called plus q. Second is minus q, and the d is the distance. So the capacitor is defined as epsilon 0 A by D. Epsilon and epsilon 0 both is called electrical permittivity. A and D are the quantities, so this can be calculated. Here, capacitance in a cylindrical capacitor is shown. In cylindrical capacitor, there are two cylinders, concentric cylinders, inner cylinder and outer cylinder. The charge is given to inner cylinder and the outer cylinder got minus q charge. We have already discussed this in unit 2. The capacitance can be calculated using this formula. 2 pi epsilon A over log of B by A. L is the cylinder length, capacitor is the, and capacitance is the in a spherical capacitor we have discussed. This is another kind of capacitor, spherical capacitor, in which the capacitance in an isolated sphere can be calculated, or the box, these two concentric sphere can be calculated. The charge is given to inner sphere and outer is grounded. The capacitance can be written as 4 pi epsilon AB over B minus A. If you are having only an isolated capacitor, then will be 4 pi epsilon R. Capacitor can also be used in various networks, as we have discussed resistors. If we put capacitor in series, then the total capacitance can be written as 1 upon C total is equal to 1 upon C1 plus 1 upon C2. This is different than resistor. As suppose you keep your capacitors in parallel, then this value will be C total is equal to C1 plus C2. Both will be added. Just remember, in resistance, the position is reverse. Another third important component, inductance, inductor. Inductor gives inductance. We have discussed resistors, capacitor. The third is also important. That is inductance. Now we have introduced one more thing, that is magnetic field. Before this we were discussing only electric field. The capacitor store energy in electric field. The inductor store energy in magnetic field. Inductance is the inductor capacity to resist variation of electric current, and this is measured in Henry's H. The inductor is more than a rolled wire in a spiral which can a nucleus inside to increase the magnetic field and inductance. In the figure, we have shown many types of inductors. I have already discussed in the previous unit solenoids, toroids, and all this we have to wrap wires in the form of spirals or something. We have to roll the wire either on a tube or on some disc, so that to create inductance. We also use these type of things. Inductors are more effective. You must realize this. The formula to calculate inductance is this: L mu n square A over L. Here mu is the permeability, as we have discussed epsilon there, permittivity. This is permeability. N is the number of spirals or wraps you have done. turns. A is the cross-sectional area and L is the length. The inductor association in series and parallel is equal to resistors, and total inductance is calculated in the same way as we do in the resistance. So we have discussed resistor, capacitor, inductor, and how can we use these in various circuits. Soon we will discuss how to use these things in combination. In alternate current, the value of resistance in the passive components like resistor, capacitor and inductor is called impedance, which is formed by reactances. In the resistor, the impedance is equal to resistance value in the circuit. In capacitor and inductor, the reactance is an imaginary number that are called capacitive reactance or inductive reactance. We should keep in mind because in the next lecture we will use these terms. You will learn these things in lab also. You already did some practicals related with Kirchhoff law in the lab. I've also told you then you can develop some projects on these things. I suggest you to create some visual projects if you can. Here I have shown this word capacitive reactance. If C is the capacitance, then capacitive reactance is defined as Xc, and this is always equal to 1 upon omega C. Omega is called frequency in radians per second. So Xc is equal to 1 upon omega C. Now you can learn the things. Omega is the frequency. For AC current, we have some frequency. Since you have some frequency, you will have some reactance. What will happen if the frequency is 0? Yes, if the frequency is 0, the Xc will be infinite. And when the frequency will be 0? The frequency will be 0 in DC current. The frequency is 0 means infinite capacitance, infinite reactance, capacitive reactance. Capacitive reactance is infinite means this will not allow to pass. Capacitor don't allow direct currents. Here you can learn. These things are not to remember always. If you know the value of capacitive reactance, then you can check why DC is not allowed in capacitors. We use this property to filter DC from AC. As we all know, in many electronic devices we need AC. In many electronic devices we need DC. And DC can be created by alternating currents by using filters or some device circuits. This is the way. Inductive reactance is another word for inductors, and this reactance is XL is equal to omega L. Remember this. In capacitance, this omega came in denominator, but here it is numerator. The graphic shows the impedance, reactance as XC and XL imaginary and resistance in real number. I'm will show in the next slide, but this is the opposite than capacitor. Here I have concluded the impedance of capacitor and inductor. ZC is equal to 1 upon j omega c and ZL is equal to j omega L. J is used to represent you that these values are imaginary. In the figure, see, the R is resistance. If R in an X direction, then the resistance and capacitance can be calculated. The capacitance, impedance of capacitor I have shown in downward and reactance in upward. Check this. The inductance move forward or capacitor lagging behind by 90 and this is forward by 90. If we know XL, we know XC, XL omega L, XC 1 upon omega C, then we can calculate total. Then total Z can be done as R plus J XL minus XC. XL and X minus XC depends on which is more is higher. So the total impedance is ZR plus ZL plus ZC. And we have discussed all. The next lecture will be more detail on these activities. Thank you all for this lecture. Again, I'm reminding you, take the reference either from your book RP Goyal or from other references. Note down these lectures. I have also added many content in this unit. Cover your topics from those units also. Soon I am also uploading assignments. So read this, study hard. At least give 3 to 4 hours daily for studies. Thank you.